video is going to walk you through how to graph linear inequalities. So there's a big difference between graphing linear equations, which is what we did in Unit 1, and graphing linear inequalities. The two biggest differences are, one, in how we connect the points. So if the inequality is just a greater than symbol or a less than symbol, it's going to be a dashed line, which is going to look like this on a graph. Okay, so that's if it's just a greater than or a less than symbol. If it's greater than equal to, less than or equal to, or just a regular equation, then you would have a solid line. The second big difference is that for inequalities, there are more solutions than if you have an equal sign. If x equals 7, then x just equals 7, but if x is greater than 7, you have infinite solutions for what x could be. So when you're graphing a linear inequality, you are either going to shade above the line, so that would look like this, if it is a greater than symbol, or if it's less than, then you would shade everything below the line. And we are going to, you'll see as we move through this PowerPoint, that you are going to be utilizing Desmos to help you with the shading. So when we plug these inequalities into Desmos, you'll be able to see whether it's a solid line or a dashed line, and you'll also be able to see whether the shading is above or below the line. If it's an inequality, though, it's important that it has to be shaded. The solutions then are going to be any coordinate that is in that shaded region. So if I'm looking at these that I drew above, a point here would be a solution. A point here would be a solution, okay? Any point that falls in that shaded region is a solution to the inequality. You can also do what we did yesterday and take the points and plug it into the inequality and see if it yields a true or a false statement. But now that we're looking at a graph, we can just look for points that are in the shaded region. If it's not in the shaded region, then it would be a non-solution. For any point that falls on the line, if it is a point on a solid line, it is a solution. If it is a point on a dashed line, then it is a non-solution. Okay, so let's look at graphing something that is in slope-intercept form. You guys have all seen slope-intercept form before, and this picture over here is what the graph would look like in Desmos. So I'm going to talk about Desmos in a minute, and I would recommend maybe while you're watching this video to periodically press pause and try to type the inequality into Desmos on your own to see what it looks like on your computer screen. You can zoom in, you can zoom out, you can change the color of the line, all sorts of things. So when I'm looking at this inequality, the first thing I'm going to look for is the y-intercept, because that's my starting value. So my y-intercept is 4. So I'm going to write that as 0, 4. Whoops. 0, 4. Okay, and then this value is my slope, so -2/5. So to graph something that's in slope-intercept form, we always start with our y-intercept. You have to start at a point. It doesn't have to be the y-intercept, but in slope-intercept form, it gives me the y-intercept. So I would start at 4, and then my slope is -2/5, which means I'm going to go down 2 and right 5. You could also go up 2 and then left 5. Either way, it would give you a negative. So down 2, right 5, down 2, right 5. Then we need to pay attention to whether or not this is going to be a solid line or a dashed line. So because my inequality is just less or greater than, that means that the line is going to be dashed. And as you can see from the Desmos screenshot, this is showing us that it's a dashed line. So it should be something like this. And y'all should be using her ruler. Obviously mine is not as great writing it on the computer screen. So then for the shading, because my inequality is greater than, I am going to shade everything that is above the line. And again, you guys can utilize Desmos to help you with that. And you can see that it's shaded above in Desmos. So that's where I want to shade above for my inequality. So any point that falls in that shaded region is a solution. So is the point -6, 10 a solution? That point would be up here. And so yes, it is a solution. Example 2 is very similar. Y is less than or equal to 2x plus 3. That's also in slope-intercept form. So my y-intercept is at 0, 3. And that's where we would start. So you can go ahead and put a point at 3. And you can check with Desmos. Now notice on the screen on the right with Desmos, my scale is a little bit off because it's going by 2. So I can see right here that that's the y-intercept at 3. When you're in Desmos, you can zoom in to have the scale go by every 1, and then you would be able to see that that point is at 3. Okay, and then my slope is a positive 2. If your slope is a whole number, you can always put it over 1 to graph it. If my slope is positive 2, that means that I would go up 2 and then right 1. You could also go left 2 or left 1, but then you would need to go down 2. So you'd have to go either a negative over a negative or a positive over a positive to make the line positive. Down 2 over 1. Technically, you only need 2 points to be able to connect the dots. So this is plenty of points here, and this is going to be a solid line because it's less than or equal to. Okay, and then for the shading, because this is less than or equal to, I am going to shade everything that is below this line. And again, I just want to reiterate to please make sure that you are using a ruler when you're connecting these points. All right, so 6, -1 would be right here. 6, -1, and yes, that would be in the shaded area, so yes, that is a solution. Example 3 is a little bit different from what you guys have seen before because this is not in slope-intercept form. This is in standard form. So to find the slope and the y-intercept in Desmos can be a little bit tricky. Now the y-intercept might not be as difficult. You can zoom in, you can click in Desmos, like where it hits the y-axis to see where that point would be, and that is at 0, -2. For the slope, you've got 2 choices. You can either continue to zoom in on Desmos and try to figure out where do you see another point that hits nicely and then count your rise over run, or you can take this inequality and change it into slope-intercept form. So to do that, I would need to get the y all by itself. So I can take the 3x and move it to the other side by subtracting it since it's positive. It's going to be very similar steps to if you were solving an inequality. The only difference here is that since I have 2 variables, I'm not actually solving anything. I'm just manipulating this equation and moving things around so that it looks like slope-intercept form. So on the right-hand side, the -3x is now over here, and the -18 is still on that side. And I put the -3x in front since I want it to be an mx plus b. And then we can divide everything by 9. So y is less than. -3 divided by 9 is going to give me a fraction. I don't want to write it as a decimal. 1, because we would have to round it. 2, because it's my slope. So it's okay for it to be a fraction because that's my rise over run. So this would simplify to be -1/3x and then -2. And Desmos will simplify fractions for you. So if you think you're going to have trouble with -3/9, you can type that into the online calculator and it will give you -1/3 as the answer. Okay. And then we can see -2, check, that's what Desmos graph does our y-intercept. And now I have the slope is -1/3. So that's going to make it just a little bit easier for us to produce the graph on our paper, because I could see the -2 and I could see the -6 as the x-intercept, so we could have plotted that, but you're not always going to have the x-intercept. So it's nice to know what the slope is to be able to help you to graph it. So we would go up 1/3 or down 1 and then right 3. Okay, and then my inequality is just less than, which means that this should be a dashed line. And it's less than, which means I would shade below. So is the point -3, -1 a solution? So where is that point? -3, -1 is right here, which actually falls on the line. So the question is a point that falls on the line a solution or not a solution? It depends. If it is a solid line, then yes, it is a solution. If it is a dashed line, then no, it is not a solution. Our last example, we're going to graph -4x plus 2y is greater than or equal to 12. So again, as you guys get used to doing these problems, you can utilize Desmos and find the points and use that to create your graph. Or you can take this inequality like I did on the last example and manipulate it into slope-intercept form. So again, to do that, I would move the x to the other side of the inequality. I'm not combining the 12 and the 4x together. I'm just moving that x to the right-hand side. And then I would divide everything by 2 so that I have y by itself. So y is greater than or equal to 4 divided by 2 is 2, and 12 divided by 2 is 6. Then I have my y-intercept is at 6, and my slope is 2. So I would start at 6, which matches up with what is on the Desmos graph. And then if my slope is 2, I can either go up 2 over 1, or I can go down 2 and then left 1. Okay, and then this inequality is greater than or equal to, which means that this should be a solid line. And my shading, because this inequality is greater than, my shading will be above. For the solution, non-solution, you have choices. A solution is going to be any point that falls into that shaded region or on the line, since this is a solid line. So I could do -10, +10. That would be in the shaded area. And for my non-solution, I could do 6, 2. Right here, this is not in the shaded area, so that would not be a solution.